Assessment in mathematics has a direct impact upon our students' teaching and learning experience. Assessment is the process of gathering and interpreting evidence to make judgments about student learning. It's used by both learners and teachers to decide where their learners are at in their learning, where they need to go, and how best to get there. The purpose is to improve learning, inform teaching, help students achieve the highest standards they can, and provide meaningful reports on students' achievement. Assessment can be diagnostic, before learning takes place, formative, ongoing throughout the learning process, and summative, typically used to evaluate the effectiveness of instruction and student competency at the end of an instructional phase. If students are to develop a complete mathematical range of knowledge, processing and thinking, then all the goals of the mathematical curriculum need to be assessed. Common misconceptions are that only the answers count and that being good at math means being able to do things quickly. Thoughtful consideration of a problem or investigation before it is begun, and any reflection on the answer or method of solution when it is completed, should be just as highly valued. Show you're working, tell us what's going on in your mind, are phrases employed to help prioritise the way answers are obtained and the thinking that allows new problems to be tackled. Formative assessment or assessment for learning helps teachers make informed decisions about the varied aspects of their day-to-day work, planning instruction, making teaching decisions, monitoring student progress, and evaluating student achievement. Observation, questioning, and portfolios are three formative assessment strategies making up pieces of the assessment puzzle. Observation is the most commonly used formative assessment strategy. Observing students as they work and making judgments about their performance provides a solid foundation for successful planning and differentiation. Observation does not have to be limited to teacher v student. Students observing each other facilitates the creation of checking mechanisms, such as self-assessment and peer guidance. The more engaged with each other students become, the stronger learning community established, enhancing motivation by breaking down those nervous barriers of embarrassment surrounding failure. In order for observation to be worthwhile, teachers must have clear goals to evaluate and record. For example, Year 4, recalling multiplication facts up to 10 and related division facts. Math games are designed for collaborative group work such as speed counting, the counting game, and dots and dashes, all allowed to demonstrate their ability to count in their assigned multiples. Group work frees the teacher up to observe individual students, pairs, and group dynamics as they play each game. A checklist with predetermined goals simplifies the record keeping and minimises any distraction created by being watched. As a final observation, students are to adopt a thumbs-up self-reflection on their learning experience. This too would be recordable on the checklist and allows for consolidation of key concepts. Teaching students the value of questioning in mathematics not only makes them more active participants in their learning, it allows the teacher insight into their thinking process and problem-solving techniques. This collaborative discussion-based approach encourages students to take risks, speak up, orally pursue complicated issues, and talk through their thinking process. Similar to observation, students are engaged with each other rather than solely with the teacher, again reinforcing their community of learning. Greater success occurs when questions are planned and yes, no, or one-word answer questions are avoided. For example, Year 5, investigating strategies to solve problems involving addition and subtraction of fractions with the same denominator. By providing one interactive example for each student, pair and table discussion opportunities, and asking all students to independently work on a set of consolidation questions to mark as a class, the teachers and the students have the opportunity to question and discuss all strategies employed. The teacher makes notations on a checklist to indicate understanding. As a final self-assessment, teachers ask the students to engage in peer discussion before independently completing a 3-2-1 or exit slip. Portfolios are the most complete way to evaluate a student's work over time. They demonstrate the gradual progression of student learning and comprise all manner of work samples. Portfolios can be very time-consuming to compile. They also need a clear rationale or plan to be established. For example, having the students choose a certain number of items to include each teaching period gives them ownership of their learning, allowing them to take responsibility for their engagement and become intrinsically motivated. For example, Year 3, describe, continue, and create number patterns resulting from performing addition or subtraction. A special project sample demonstrating each student's ability to construct simple number patterns to challenge their classmates. The task is differentiated for all learners, comprising clear scaffolding for those who need it and a challenge aspect for those who would benefit from extension opportunities. The importance of purposeful, planned, detailed record keeping has been made clear throughout this presentation. Be mindful of becoming enslaved to this process. Set goals, be flexible, adapt to your students, and involve them in the decision-making process. Assessment needs to be clearly planned and implemented as part of the learning process to provide all students with intrinsic motivation, creative and critical thinking skills, and a safe and supportive environment to maximise a student's teaching and learning experience. Feel free to contact me for a copy of this or any lesson plans here, and here are the references. Thank you.